All right, ladies and gentlemen, today we're doing lesson 5.7, expressing transformations of functions algebraically. Now it's a combination of what we've been doing this week. In lesson 5.5, we talked about the graphs, like being able to describe what the graph does. Uh, and then in 5.6, we talked about how the equations match the graphs and show the movement. So today we're going to sort of combine all of that together, uh, along with what we did last week, where we translated graphs up, down, left, right. And so we'll talk about what they mean. So this is the warm-up. Now, you should be following along you should get a paper from the sub if you haven't already, and you should be following along by filling in these notes. You should also be answering the questions that are assigned with this video. And then, of course, when the lesson is done, you should be completing your cool down. So um, today's going to look just like it normally does. So let's jump in. If I have this equation, g of x is equal to the square root of x, that is our function that we're going to translate, because that's in the first warm-up, it's called describing translations. So we're talking about up, left, down, right movement. So as review, I want you to see that in this one right here, in row number 1, we are translating the graph left 5 units. Now we learned that in order for it to go left or right, we have to change what's inside the parentheses. On top of that, since we're going left, we assume that would be a negative movement, but we have to complete the opposite movement. So that's why it's x plus 5. Now, the function notation says g of x plus 5, but what does that look like in our expression? Well, we know g of x is the square root of x, so instead of having instead of having x inside the square root, we're going to have x plus 5 in the square root. So it's saying replace x with x plus 5, and then replace that in our expression. So when we look at the next one, step 2, it says that we are translating left 5 units and then down 3 units. So we're translating left 5 units like we did in step 1, but we're also going down 3 units. Now, we talked about downward movement as being on the outside, right? Outside, and it's negative. Like minus 5 means going down 5. And then we already talked about left movement is inside the parentheses. So if I have g of x on the inside, I'm going to go left 5, but that means x plus 5 because it's opposite. And then when I go down 3, that tells me on the outside I need to go minus 3. Now that matches up with our equation on the right here in our expression. G of x is a square root graph, so we're going to just put the square root of x plus 5, and then outside of the square root, we just do minus 3. So something a little interesting happens here. In this next box, we have the function notation and the expression, but we need to find the words. What is it telling us to do? Well, we are seeing a negative movement. We've changed x to negative x to negative x inside the parentheses. We know that from lesson 5.5, if I change x to negative x inside the parentheses, that means I'm reflecting across the y-axis, right? So if you go back to your notes from 5.5, you'll see that we're reflecting across the y-axis. So that's what's happening here. We are reflected across the y-axis. Good. So that's what we did there. And to follow that up, we replaced our equation with x, we replace it with negative x. Because normally it's supposed to look like this, but now we're modifying that equation depending on what the graph is doing. Okay? Now, for step 4, it's probably the most important piece of today's lesson. Can we combine all of these things that are happening to the graph? And this is how we do it. Okay? So, what we're going to do is to show the function notation, we know that we're going to have a negative inside the parentheses, but we also need to put another parentheses inside that, similar to what we did in lesson 5.6. I'm going to have my x plus 5 here, and so on top of that, I need to close the parentheses, and I also need to put my minus 3 out here. So several things are happening. One, this x plus 5 tells me to translate left 5. This negative tells me to reflect across the y-axis. And this equation here, or the minus 3 here, is telling me to go down 3. So many things are happening in this one equation. How do we show that algebraically with our expression? We know that g of x is a square root graph, so I'm going to put my square root there. Actually, let me go back to pink. I'm going to put my square root there, and then I'm going to put my negative, and then my x plus 5 inside the parentheses. Okay? My x plus 5 inside the parentheses, all of that underneath the square root, and then I have to put my minus 3 on the end. So this graph right here, this equation, does all of the things in this box. We're moving it left, we're translating it down, then we're flipping it across the y-axis. So it does all these things at once. Yeah. I wish I could show you. Maybe I can. What if, let's go to Chrome, we're going to go to Desmos. We're going to go to Desmos. And if I have my y equals, where is it? Oh, here it is. Square root of x. That's what the graph normally looks like. Now, when I put in my y equals square root of x plus 5, what it's done is it's shifted to the left 5 spaces. I also want it to go down 3, so I'm going to make sure it's outside the square root. I'm going to go minus 3, and not only has it shifted to the left 5, but it's gone down 3. Finally, the last step is for me to do y equals square root of negative parentheses x plus 5, close the parentheses. So you can already see this graph moved to the left 5 spaces and then it flipped, right? And then it flipped, but then I also need to bring it down, oops, minus 3, minus 3. So you can see that's what we wanted the graph to do. It went to the left 5, and then it went down 3, and then it flipped. So that is how we represent reflection. So let's go back to our notes. What I want to do is now we can do the same thing with other types of functions. So for 7.2, we're translating vertex form. So vertex form is a form of a parabola that shows me the vertex of the graph. So if I have my original equation, y equals, or f of x equals x squared, this is the graph of a parabola, okay? It's always a parabola, and to be, just to remind you, it's the normal graph looks just like that. It's going through the origin right here, and it looks like a U, okay? That's my y equals x squared. What I'm going to do is I'm going to write an equation for this function g of x, whose graph is just like f of x, but it's translated 3 units left and 5 units up. So 3 units left means plus 3 inside, and 5 units up means plus 5 outside. Okay? So we would show this in function notation like this. It would be g of x equals f of x plus 3 plus 5. So it's saying g of x, the graph of g of x, is just like f of x, but it's shifted 3 units to the left and 5 units up. So then I need to write my actual formula using my x squared graph. So normally my x squared looks like this, but now I need to put x plus 3 in there. So I'm going to write x plus 3 squared and then plus 5. So this takes my x squared graph and it makes it go 3 left and 5 up. And I'm going to show you on the graph right now how that works. So if I go back, and now I have my y equals x squared. It's my normal U-shaped graph. Okay, that's what it always looks like. But now I'm going to take the graph and I'm going to shift it to the left 3, so that's x plus 3, and then squared. So I already shifted it to the left. The black graph goes to the left, but I also want to shift it 5 units up, plus 5. Great. So I shifted it to the left 3, up 5. That's what I wanted to do. But I want to draw your attention to this point right here. That point at the bottom of the curve, the bottom of the parabola, is called the vertex. And I want you to see how you could visualize the vertex in the equation. In the equation, or in the problem, didn't it ask us to go 3 units left, and 5 units up? So my vertex was normally at 0, 0 here, but do you notice now I've shifted the entire graph to negative 3, 5. Negative 3 tells me I went to the left 3, and 5 tells me I went up 5. So it says, what is the vertex of the graph of G? I would say that the vertex is negative 3, 5. This is because, you can put BC, this is because the graph, the original vertex is at 0, 0, but the graph was shifted, or translated, was shifted 3 units left or x equals -3 and 5 units up, which is y equals +5. So therefore, I end up with -3, 5. So this equation in vertex form allows us to, so this equation right here in vertex form allows us to find the vertex. That's why it's called the vertex form. So it said here, write an equation. Let me go switch colors. Now it says for number 3, write an equation for a function h of x that has a vertex here. This is the x and this is the y. Now that we know the vertex, we can write the equation. It's going to look, so h of x is going to be something in parentheses x squared and then with something on the outside. Well, this 1.5, it's positive in the x direction, but that tells me to go negative in the x direction. So that's really telling me in my equation, this would be on the right side, but in my equation, I have to do the opposite. So I'm going to write minus 1.5. So this means write 1.5, but I have to put negative in my equation. And this tells me 2.6. So up 2.6. Well, to show up 2.6, I just need to add 2.6. Now, I'm going to go back to my graph and make this, I'm going to type in this equation, and you're going to see it's going to do what we want it to do. It's going to give it this new vertex. So I'm going to get rid of this one. I'm going to say y equals, or h of x, in this case, equals parentheses x minus 1.5. Oops, not 15. 1.5. Close that parentheses. It is now squared. So look, I already went to the right. 1.5. So if you click on this, I already went to the right 1.5. I'm going to go back to my equation, and I need to go up 2.6, not 26, 0.6. So if I look at this graph right here, guess what? There's my vertex for the red graph. So you should be able to write an equation when you know the vertex, or find the vertex when you know the equation. You might even remember this from 9th grade. The performance task where you had to find a parabola in like a picture and you had to graph it, and you had to do it in 3 different forms, in standard form, factored form, and vertex form. Like we actually did this back in 9th grade. So write an equation for a quadratic function k whose graph opens downward and has a vertex of 3.2, negative 4.7. So I think we can do the vertex form pretty quickly, but something new is here. This opens downward. You may remember that from when we graphed polynomials, but let's do the vertex form first. So k of x is equal to x and something, x with something, and then parentheses squared, and then something on the outside. I know my 3.2 is positive, that's my x value. That tells me to go to the right 3.2, but in my equation I want to do minus 3.2 on the inside. And then I have negative 4.7. That tells me to go down 4.7. So I need to put that on the outside, minus 4.7. Now, what we're going to do is we're going to go to the graph, and we're going to figure out how to make it open downwards. So I'm going to graph this first. So I'm just going to edit this equation here. Minus 3.2, and then minus 4.7. So the graph moved. It went to the left, it went to the right 3.2, and then went down 4.7. So that's my new vertex, which is what I want. But it also says that I want it to open downwards. So what I'm going to do to make it open downwards is I want it to essentially flip. I want it to flip, and we learned that if I want to make it flip vertically, I need to change the outside of the equation. So what I'm going to do, I'm going to take my equation, I'm just going to put a negative in front of it. So let's see that happen again. My graph is going up at that vertex, but I want it to open downwards. So now, if it does, now I have it opening downwards. And I do that by putting that negative out there. So the big key thing is this negative right here. So let's review. It did a lot of things. Number one, this told me to go down 4.7. This told me to go right 3.2. And this told me to flip downward. So our goal today was to be able to take a look at an equation and modify it to make it do the things we want it to do. We talked about three types of movement today. We talked about moving it left and right, which is the inside and its opposite. We talked about moving it up and down, which is the outside over here, like the negative 4.7 on the right. And then we wanted to flip it, so we have to put a negative out there to make it flip. And that's it. Those are the three basic things. Let's take a look at some practice problems that I gave you. I want you to see, it says here's a graph of f of x equals e of x. So this is my original graph right here. F of x equals e to the power of x. So it's just an exponential graph, okay, which has a y-intercept at 0, 1. Okay, a y-intercept right there. G of x is a transformation of f. So how did f change? How did f change to become g? Well, I want you to picture the point was here, but it looks like if I were to draw the reflection, of g of x, doesn't it look like this point moved over 2 spaces? So we see movement, we see translate right by 2. We see translate right by 2 because we go from 0 to 2. Now, we need to then take the graph and then flip it downwards. So we need to figure out how to change this equation in order to make it make sense. Okay? So we can say this: g of x is equal to f of x, but on the inside it went to the right 2, so now it's going to go x minus 2 on the inside, but it also flipped. So I'm going to put this negative out here. I'm going to put a negative out there. So how does that look in the equation? G of x is equal to e to the power of x minus 2. That's what I put inside my equation. Instead of x, I put x minus 2. And I made it flip, so I'm going to make it negative on the outside. Let's take a look and see if that actually worked. So I'm going to go and graph these two equations in Desmos. So my e function should be here somewhere. Actually, I can just do this. E to the power of x. So there's the graph that we just saw, e to the power of x. And my vertex is now right there. Sorry, not my vertex, but my y-intercept. And I want to make the graph shift to the right 2 and then flip over the axis. So my new equation became y equals negative e to the power of x. Oh, look, it shifted. It flipped upside down. But then I want to make it go to the right 2. So I'm going to put minus. Oops, sorry. This should be in the exponent. Be careful when you type these, because they should be in the exponent. Why does it keep doing that? Oh, you know what? Let me put parentheses. Parentheses, there we go. X minus 2. Boom. So what has now happened is that I should have a point at to negative 1. So the point has moved from here at 0, 1 to the point here at 2, negative 1. Cool? So we've now shifted it. So I changed the x. I wanted it to go to the right 2, so I put x minus 2. And then I wanted it to flip, so I put a negative in front. Let's take a look at several more examples, in fact. What you're going to do is you're going to look at these equations from f to x going to g of x, and you're going to describe the movement. So let's take a look at the first one. When you are looking at this negative, you know it's going to flip downward. And you know that this plus 2.7 is on the outside of the function. It's not with the x, it's outside. So that means it has to go up 2.7. So that's really it. Those are the two things that happened. One, it went up 2.7, and two, it flipped downward. That's it. Now, those motions can happen in any order. That's completely fine. Let's take a look at B. Let's take a look at B. 3 things happened. So there's that one thing, this thing, and this thing. So we have to talk about those movements. How did it change? We know that negative, just like before, the negative made it flip downward. At step 2, it's negative on the inside. So we're talking about left and right movement. In this case, it's negative, so it's going to go to the right. So it's going to translate 3.1 to the right. And then the plus 1 tells me, for number 3, it tells me it goes up 1. Translate up 1. That's it. That's all. Now, we're going to get to some fancier graphs, but I want you to not panic. I want you to see that like the absolute value graph, for example, does the same exact thing as the other equations. So let's take a look at C. C only does one thing. What does it do? It goes, this is the one thing, it goes down, because it's negative, it goes down 26 units. So it just drops. So the absolute value graph actually looks like a V, a straight V, and the vertex is normally at 0, 0, and it just drops all the way down to 26. We could see that on a graph, but I think you get the picture. It's just going to slide down. And then finally, our square root graph, like we were looking at earlier, it's doing 2 things. Here is the negative on the outside, and we are subtracting 0.004 on the inside. Well, it's doing two things. I know one, just like all the others, it makes it flip downward. And for number two, it is negative, so it's going to the right on the inside. It's going to the right. So it goes to the right 0.004 spaces. It's a really, really small space. It barely moves. And yeah, I mean, that's the lesson. The goal was for us to write an equation from a description of how a graph is transformed. So am I able to, given words, can I make an equation that would describe, it would make the graph do the things that I wanted to do. So now that you finish these notes, you should, you need to get to your cooldown. It's already published on Canvas. So it's going to ask you several questions very similar to today's work. So trust what you know. As long as you took good notes and as long as you're paying attention, you know exactly how to do this work. And of course, you can go back and rewind the video if you missed anything or you want to go back and just watch it again. Cool? All right. Good luck.